Hello, welcome back to this channel. I am Christopher. Take a moment to pause, breathe and settle in, because today we are beginning a journey into one of the most fascinating ideas of our time, artificial intelligence. You may have heard people talk about AI as something magical, something powerful, or even something mysterious. We see it writing stories, creating art, answering questions, recommending videos, and helping scientists discover new possibilities. But behind all of this lies a very human question. How does AI actually work? In this video we will explore that question together, slowly, clearly, and thoughtfully. Think of this not as a technical lecture, but as a guided exploration for seekers who want true understanding rather than surface-level explanations. We will look beyond the headlines and simplify complex ideas without losing depth. Drawing inspiration from influential books such as Artificial Intelligence, A Modern Approach by Stuart Russell and Peter Norvig, DeepLearning by Ian Goodfellow and colleagues, The Master Algorithm by Pedro Domingos, and Life 3.0 by Max Tegmark, we will connect mathematics, learning, and human intelligence into one coherent picture. You don't need to be a programmer or a scientist to follow along. All you need is curiosity. Together we'll uncover how machines learn from data, how neural networks imitate patterns found in nature, and why language models can seem so intelligent despite working very differently from the human mind. By the end of this journey, my hope is that AI feels less like a mystery and more like a tool, one shaped by human choices, human knowledge, and human responsibility. So if you're ready, let us begin gently and step by step as we explore not just what AI does, but how it truly works. What is AI really? Before we can understand how artificial intelligence works, we must first understand what we truly mean by the word intelligence. When humans describe intelligence, we often think about reasoning, learning from experience, solving problems, recognizing patterns, or adapting to new situations. Artificial intelligence, or AI, is the scientific effort to recreate some of these abilities in machines, not by copying the human mind exactly, but by building systems that can perform tasks that normally require human thinking. AI is often misunderstood as a single technology, but in truth it is a broad field that combines mathematics, computer science, logic, psychology, and neuroscience. As described in Artificial Intelligence, A Modern Approach, AI is essentially the study of intelligent agents, systems that perceive their environment and take actions to achieve goals. It is important to remember that today's AI is not conscious. It does not possess feelings, intentions, or awareness. Instead, it identifies patterns and makes predictions based on data it has learned from. You can think of AI as a powerful pattern recognition engine. For example, when an AI recognizes an image, translates language, or answers a question, it is not thinking like a human. It is using learned statistical relationships to produce an output that appears intelligent. AI can be understood in three broad categories: narrow AI, designed for specific tasks like recommendations or voice assistance; general AI, a theoretical system capable of human-level reasoning across many domains; superintelligent AI, a future concept discussed in philosophical works like Life 3.0. Today, almost everything we call AI belongs to narrow AI, powerful, yet specialized. Understanding this removes much of the mystery. AI is not magic. It is human knowledge encoded into algorithms, guided by data, and shaped by our design choices. And with this foundation we can now move to the next question. How does AI actually learn? Data, the foundation of learning. Now that we understand what AI is, we can explore the most important idea behind its learning process: data. If intelligence grows through experience, then for artificial intelligence, data is experience. Imagine teaching a child to recognize a tree. You would not write a long list of rules describing branches, leaves, or shapes. Instead, you would simply show many examples. Over time, the child begins to recognize patterns naturally. AI learns in a very similar way. Data can be many forms: words in books, images on the internet, sounds, videos, numbers, or even human decisions recorded over time. Each piece of data acts like a small lesson. When millions or billions of these lessons are combined, patterns begin to emerge. The goal of AI is to discover these hidden patterns and use them to make predictions. In simple terms, the process looks like this. Keycap 1 input, the information given to the system. Keycap 2 pattern discovery, identifying relationships within the data. Keycap 3 prediction or output, using those patterns to produce an answer. As Pedro Domingos describes in The Master Algorithm, learning is essentially the search for patterns that best explain past data and help predict future outcomes. However, data is not neutral. If the data is incomplete, biased, or inaccurate, the AI will reflect those limitations. This is one of the most important realities in modern AI ethics. Machines learn not only knowledge, but also human imperfections embedded in data. You can think of data as the soil in which AI grows. Rich, diverse, and carefully prepared data helps intelligence flourish. Poor data limits understanding. With this foundation in place, the next step is to understand the methods machines use to learn from data, a field known as machine learning. Machine learning, teaching machines to learn. Now that we understand the importance of data, let us explore the process that turns data into intelligence. Machine learning. In traditional programming, humans write clear instructions for every step a computer must follow. If you want the computer to solve a problem, you must define the rules yourself. But the real world is often too complex for fixed rules. Language, images, and human behavior contain endless variations. Machine learning changes the approach entirely. Instead of telling the computer how to solve a problem, we give it examples and allow it to discover the rules on its own. This shift, from explicit programming to learning from experience, is what makes modern AI possible. There are three major ways machines learn. Keycap 1. Supervised learning. Here, the AI learns from labeled examples. Imagine showing thousands of emails marked as spam or not spam. Over time, the system recognizes patterns that separate the two. Keycap 2. Unsupervised learning. In this method, the data has no labels. The AI explores and discovers hidden structures by itself, such as grouping similar customers or finding patterns in large datasets. Keycap 3. Reinforcement learning. Inspired by behavioral psychology, this approach teaches through reward and punishment. The AI tries actions, receives feedback, and gradually improves, similar to how humans learn through trial and error. This method has been used to train systems that play complex games and control robots. What is important to remember is this: machines do not understand in the human sense. They adjust internal parameters to reduce mistakes, gradually becoming more accurate. Machine learning is the bridge between raw data and intelligent behavior, and understanding it prepares us for the next step, where learning becomes even deeper through neural networks. Neural networks and deep learning. As machine learning evolved, researchers searched for ways to make systems better at understanding complex patterns such as language, images, and sound. This search led to one of the most important ideas in modern AI: neural networks. Neural networks are loosely inspired by the human brain, though they are far simpler in reality. Instead of biological neurons, they use mathematical functions arranged in layers. Each layer receives information, transforms it, and passes it forward. Let us imagine a simple example: recognizing a face in an image. The first layer might detect basic shapes and edges. The next layer combines those shapes into features like eyes or a nose. Later layers combine those features to recognize an entire face. This layered learning allows the system to build understanding gradually, moving from simple patterns to complex concepts. When these networks contain many layers, we call it deep learning. As explained in the book Deep Learning by Goodfellow, Benjo, and Corville, depth allows models to learn rich representations directly from raw data, reducing the need for manual feature design by humans. Three key factors made deep learning successful: massive datasets available from the digital world, powerful hardware such as GPUs for faster computation, improved training methods that stabilize learning. During training, the network makes predictions, compares them to the correct answer, and then adjusts internal weights to reduce errors. This process repeats thousands or millions of times, gradually improving accuracy. Despite the name, neural networks do not think or reason like humans. They are advanced pattern translators, finding relationships too complex for traditional programming. Deep learning has enabled breakthroughs in speech recognition, medical imaging, translation, and content generation, setting the stage for the next leap in AI. Language models that can understand and generate human-like text. How language models work. Now we arrive at one of the most fascinating parts of modern AI: language models, the technology behind systems that can write, explain, translate, and hold conversations. At first glance, their ability seems almost human. But their core idea is surprisingly simple. A language model learns to predict the next word in a sequence. Imagine reading a sentence like, "The sun rises in the..." Your mind naturally expects the word east. Language models learn this same predictive ability but on an enormous scale. During training, the model reads vast amounts of text, books, articles, conversations, and more. It doesn't memorize sentences like a database. Instead, it learns patterns about how words, ideas, and concepts relate to one another across different contexts. The major breakthrough that made modern language AI possible is the transformer architecture, introduced in the research paper Attention is All You Need. Its key innovation is something called attention. Attention allows the model to focus on the most relevant words in a sentence when deciding meaning. Just as humans pay attention to certain parts of a conversation, the model dynamically weighs relationships between words to understand context. Inside the model, words are transformed into mathematical representations called vectors, allowing meaning to be processed numerically. Through billions of training adjustments, the system gradually learns grammar, facts, style, and reasoning patterns from language itself. It is important to remember that language models do not possess consciousness or true understanding. They generate responses based on learned probabilities, choosing what is most likely to come next given the context. Yet when trained at massive scale, these predictions can appear remarkably thoughtful and coherent. Language models demonstrate an extraordinary truth. Complex behavior can emerge from simple rules repeated millions of times, a concept that echoes ideas from both computer science and cognitive psychology. And with this power comes responsibility, which leads us to the final section: limitations, ethics, and the future of AI. Limitations, ethics, and the future of AI. As we explore the power of artificial intelligence, it is equally important to understand its limits and the responsibilities that come with it. AI systems can analyze massive amounts of information, detect patterns, and generate useful outputs. But they are not perfect and they are not human. They do not possess consciousness, emotions, or genuine understanding. Instead, they operate through statistical prediction based on data they have seen. Because of this, AI can sometimes produce confident but incorrect answers. It may inherit biases present in training data or struggle with situations that require deep human judgment, ethics, or lived experience. Researchers and thinkers, including Stuart Russell in Human Compatible, emphasize that the central challenge of AI is alignment, ensuring that AI systems act in ways consistent with human values and long-term well-being. There are also broader societal questions. How do we use AI responsibly in education, healthcare, and decision-making? How do we protect privacy and fairness? How do we ensure AI supports human creativity rather than replacing it entirely? At the same time, the future of AI is full of possibility. Advances in efficiency, reasoning, and human-AI collaboration may help solve problems in science, medicine, and climate research. Rather than replacing humans, many experts believe AI will become a tool that amplifies human capabilities, allowing us to focus more on creativity, empathy, and critical thinking. The key insight is this: AI reflects the intentions of its creators and users. It is neither inherently good nor harmful. Its impact depends on how thoughtfully we design and apply it. As seekers of understanding, our role is not only to learn how AI works, but to ask deeper questions about how we wish to shape its future, because the future of AI is, ultimately, a human decision. As we come to the end of this journey, let us pause for a moment and reflect on what we've discovered together. Artificial intelligence may appear mysterious at first, but beneath the surface it is built from ideas that are deeply human, learning from experience, recognizing patterns, and adapting based on knowledge. From data and machine learning to neural networks and language models, AI is not magic. It is the result of decades of research, curiosity, and careful design. Yet perhaps the most important lesson is this: AI is not separate from us. It reflects human choices, the data we create, the values we prioritize, and the goals we set. Technology itself is neutral. The meaning it carries comes from how we choose to use it. As thinkers like Max Tegmark and Stuart Russell remind us, the future of AI is not only a technical question but also a human one. It invites us to balance innovation with responsibility, power with wisdom, and speed with thoughtful reflection. If you are watching this as a learner, a creator, or simply a curious mind, remember that understanding AI does not require fear or blind excitement. It simply begins with curiosity, asking questions, seeking clarity, and staying open to learning. I hope this video helped transform AI from something distant and complex into something understandable and approachable. If you found value in this journey, consider sharing it with someone else who is curious about the future of technology. And if you'd like to continue exploring, future videos could take us deeper into topics like how AI is trained, the mathematics behind neural networks, or how beginners can start learning AI step by step. Thank you for spending this time together. Until our next exploration, stay curious, keep learning, and continue asking meaningful questions.